So this is a presentation for our project from bats to bots. It is a bio-inspired robot based on bats. Next slide, please. Our project goals are following. The research question that we selected was how multimodal robots intended for aerial mobility improve their speed and agility during terrestrial locomotion through optimal action and gait pattern strategies. The focus, our focus was examining the biomechanical characteristics and wing shapes of bat and stressing on the energy efficient gliding. Then create a robotic system based on these bio inspired concepts. The scope of our research was firstly exploring the gliding mechanics of bats, then the anatomical changes that a bat wing goes through for energy efficient gliding, a better understanding of how this robotic system could be used in crowded spaces. We also explored some control algorithms to be incorporated in this project. And then finally, energy efficient design with the focus completely on the better selection of materials for our wing.
Our design was majorly inspired from three already existing designs, one of which is the Multimo Bat, which majorly focuses on gliding and leaping of the bat. Then there was the EPFL Jump Glider, which focuses on steering while the bat is in air. Then lastly, the closest design that has come to a real life bat, it is the BatBot B2. It is a bot which mimics all the characteristics of a bat. Then the key design elements of our mechanism are the 4-bar hinge joint. It is a simple 4-bar mechanism which helps in the movement of wings. Then there is the thin membrane which helps the bat glide in air. Then there are the electronics, that is servo, which helps in moving the wings. Passing on to Vivek.
For our initial prototype, we have used balsa wood for the mechanism and the mylar sheet as the wing membrane. This initial prototype can only glide and land, so we improved our mechanism. And you can see in the second picture, the improved mechanism has a gear and a flapping mechanism. Also, we improved in our wing structure. So our wing now has the vinyl sheet as well as the mylar sheet, which gives the firm hold to the wing. Uh, the techniques used over here are we used the Mujoko simulation and we used the 3D vectors for our kinematics.
For the circuitry, we are using ESP32 as our CPU, and we are attaching it with the 9 gram servo, which is connected directly to the which is connected the horns of it directly to the um, gear, so that it has a free move. It gives a free movement to the gear, and also ESP32 is connected to the servo via the GPR13 pin. So finally, we can say that the that our work is based on top of the existing research of the bat bots, and also uh, I think this is the first time we are using Mujoko to model this kind of bot. Also, it's an innovative strategy to use less energy, so because this bot can only be powered by a small 12-volt battery. Right now, it's powered by our laptop itself. Also, the prototype illustrates the application, and it's an improved robotic system which is inspired by the biorobotic biological features of the bat. The mechanism uses a classical 4-bar technique which generates force to flap the wings. Now we can see the video. Here the bat wings flaps according to a real life bat. While flapping down, it is faster, but while coming up for gliding, it's generally gets slower. So it is nearly close to the real life bat flapping mechanism. Thank you.